Hello everyone, welcome to our project about secure chat application using hybrid RSA and ESA encryption. The secure chat application is a desktop software system that enables two users to exchange encrypted text message over a local area network. The system uses hybrid encryption, meaning it combines both RSA and ESA to exchange cryptographic keys for encrypting the actual chat messages. The graphical interface was built using Qt6, which provided users with a modern, intuitive experience. Our application prioritized both performance and security, ensuring real-time message delivery while maintaining full end-to-end encryption. While most secure messaging apps like WhatsApp or Signal are built for internet-based communication, there's a lack of secure solutions specifically designed for local networks. On LAN, like those used in office, labs, or even our classrooms, have unprotected message which can be easily intercepted. We identified a gap, users who need an encrypted communication within a closed environment, and our goal was to fill this need with lightweight LAN-only messaging system that does not store data and does not rely on internet service, but still meet modern encryption standards. We set the following key objectives for our project. We use RSA encryption to form a secure key exchange between client and server. Use ES to encrypt the actual message content using a randomly generated key and initializing vector, which is IV. We also provided a Qt-based GUI that is simple and responsive. We achieved a real-time message delivery with low latency. We structured our code in a modular fashion to support future enhancements, and we also depended solely on open source tools so that others could build upon it or see what our code is, like transparency, basically. For our system agriculture, the application uses client-server agriculture. Here's how it works. The server generates a 2048-bit RSA key pair each time it starts. The client connects to the server via TCP and retrieves the server RSA public key. The client then creates a 256-bit AES session key and a 128-bit initializing vector. These values are encrypted with the RSA public key and sent to the server. Once both sides have the ES key and IV, they begin exchanging ES encrypted messages. And all these communication is happening over the TCP packet, which is ensuring like reliable delivery. So here's our encryption flow. We can see that the server starts, and this is where it creates the 2480-bit RSA key. Then the server sends back the RSA public key, where the client then generates the ES key IV with the RSA and then sends it back to the server. And then the server decrypts the ES key and the IV and sends it back. And now at this stage here, all the messages can be sent between the client and server, which is encrypted with the ESE encryption. This is basically a hybrid approach that ensures key exchange is secure and messages are very fast and not slow. The user interface plays a critical role in usability. We use Qt6 to create cross-platform GUIs for both the server, for the client and the server. The client GUI includes a text box for message input, a scrollable message log showing the chat history, buttons to connect or disconnect from the server, and labels showing the connection and encryption status. The server GUI logs all the incoming connection and messages in real time. We ensure that the controls are clearly labeled and the user gets immediate feedback when a message is sent, received, or if the connection is lost. We conducted thorough testing based on the software test document and mapped our tests to the requirements from our SRS document. We performed like four key test cases. The first one was a client connection. We confirmed that the client connect to the server correctly. The second, which is the key exchange, we verified that the RSA and ESA keys are exchanged securely. The third is we encrypted the messaging, which ensured that messages are encrypted and correctly decrypted. And the last is the network failures, which is simulated disconnections and validated proper error handling. It all All of the tested cases were passed, and we used tools like Wireshark to confirm that the data transmitted was indeed encrypted ciphertext. Here's are some of the list and main tools and libraries that we used. As you can see, Qt6 was for the GUI, Crypto, which is a very powerful C++ library for cryptographic algorithms like RSA and ESA, CMake for the actual build system for the Qt6, TCP networks, which is used for like real-time client-server communication, and lastly, Wireshark for inspecting the packet and confirming that the encryption was actually happening. All these components are free, open source, and widely adopted in the software development industry. Our secure chat application provided the following key features. It has a secure RSA key exchange with fresh key generation every session you connect to the server. EES 256-bit encryption in CBC mode with a new IV for each connection. So it stopped someone from realizing a pattern which causes security errors in the chats. We also have a real-time chat with visible messages log and instant updates. We have status indicators which show whether or not the encryption happened or if the server clients are connected or were disconnected. Um, we also have a random IV generator. This is what causes the change in the RSA and ES encryption, so that each time a new RSA and ES key is made, it's always different than the previous. And also, we have a modular code structure, so you can kind of see where everything is. Some of the limitations, like some prototypes, we only have one-to-one communication, so there's no group chat yet. We don't have like a persistent chat logs, so as soon as you disconnect from the server, it kind of gets deleted. It's not like backtraced. We don't have any voice or video transmission, so you can't send a voice chat or you can't do like a FaceTime. And lastly, it only works only over LAN and localhost in current versions, but this could be easily updated so that it can work over IP addresses and potentially over the internet to websites. Okay, for our conclusion, we successfully implemented a secure messaging application using hybrid RSA and ESA encryption. We've met all functional and non-functional requirements listed in our SRS. All the tests were passed and our system performed well under both normal and abnormal conditions. Looking forward, we plan to add support for group messaging and file sharing, also introduce user authentication and encrypted user profiles, which would also help us extend functionality to a WAN environment with secure NAT transversal connection. We also have an optional for store chat logs, so you can kind of see like the previous messages, and also we can enhance our GUI so that it has a better theme, looks more nice, and just looks better. But that was all for